This is El Profelo. In this video, we're going to talk about polar coordinates, Cartesian coordinates. We're also going to talk about directional vectors and magnitudes. And going to look at some equations of lines and equations of circles and bring things back to components of vectors. So looking at how a lot of these mathematics relate to each other. Okay, so let's go ahead and scroll up here. All right, so we have this information, and anytime you're provided information with the diagram, it's very useful to label the information provided, okay? So I'm gonna go ahead and come over here, and I'm gonna label this part right here, theta. I'm going to label this part right here alpha, and I'm going to label that part right there beta, because those are three angles that we have. And from this information, right, AOC is 42.97 degrees. COE is 80.57 degrees. And I know that theta is going to be a 180 minus alpha plus beta because they form a straight line. All right, I know that the sum of those three has to be 180 degrees. So if I do that mathematics, theta would be equal to 56.46 degrees. Okay, so we know the radius is 8. That's already labeled, so that's pretty standard. Okay, so if we want to find point C and point E in polar and in Cartesian form, okay, what we need to remember, what we need to be aware of is the following, right? To get the Cartesian form of something, we're going to need to know R cosine of theta and R sine of theta. That's going to be for the Cartesian form. And for the polar form, we would simply need to know R and theta. Okay. So just going from right to left over here, let's look at point E. Right. Well, point E, theta, we know what theta is. That's 56.46 degrees. So that means that point E in polar form would be 8 and then 56.4 degrees. Pretty straightforward, okay? In Cartesian form, right, we would need to use our calculator. We can bring our calculator out here. We would need to make sure that we are in degree mode. We are. And then I just need to do 8 cosine of 56.46 and 8 sine of 56.46. And so I have to one decimal place that E would also be given by 4.4 comma 6.7. Okay. So pretty straightforward. If I was going to do that for point C, right, if I was going to be looking at point C, I would need to know the angle for point C. And the angle for point C would be this angle all the way over here, which would be alpha plus beta. So for point C, I would have 8 comma 137.03 degrees, because alpha plus theta is going to give that. And if I did the calculations using the R cosine and the R sine, point C then is going to be negative 5.9 comma 5.5. And that would just once again be using your calculator to make those calculations. 8 cosine 137.03. Let's make sure we enter in correctly. And 8 sine 137.03. All right, so we can see where those values came from. And once again, 80.57 plus 56.46. That's where we got the 137.03. Okay. For the next portion, if we're looking at C to E and the magnitude of C to E, right? So if we're saying, hey, I want to know about that particular vector, right? So let's make this a little more clear. Starting at C, going to E. I want to know about that particular vector. Well, in order to know about that particular vector, the component form, x2 minus x1, y2 minus y1. Okay, so, and I would have that 4.4 minus and the 6.7 minus, right? Because I'm going from C to E. If I put that into my calculator, you should get 10.3 and 1.2. And notice that this does say it's not drawn to scale, so even though it looks like it's going down, based on what these angles all are for this setup, we're actually indicating that we're going up 1.2. So be careful as to whether or not your diagrams are drawn to scale. And so our magnitude, right? That magnitude of C to E, and whether you see it with double bars or a single bar, it means the same thing for our purposes. And so we're going to have the square root of 10.3 squared plus 1.2 squared. And if we put that into our calculator, we would get 10.4. Okay. Next step, if we want the equation of a circle, remember that the general form of the equation of a circle is x minus h squared plus y minus k squared is equal to r squared, where hk is the center and r is the radius. Well, in this situation, h is 0, y is 0, k is 0, and r is equal to 8. So that would be the equation for our circle. Okay. Now, if we want to get to the polar form, well, remember that x squared plus y squared is equal to r squared. So we could say, hey, r squared is going to be 64. And taking the square root, so that means that r is going to be equal to 8. Now, we only concern ourselves with the positive 8 in this case because we are simply stating that it does not matter the angle that goes out. Regardless of the angle, the distance from the origin will always be 8 in this polar form. Right? So really what this means is that we're looking at our set of points that is 8 units from the origin, or in polar coordinates, it's sometimes called the pole. Okay, so pretty straightforward there. Then next, let's say that we are looking at this line, all right? And let's say that we have this line going through the origin and through point E. All right, so let's say that we have that line. All right, and let's say that the equation of that line is y equals kx. All right, so let's slide this up. So the equation of that line is y equals kx. Okay, well, what do we know? We know that k is our slope, and we know that the slope is the change in y over the change in x. All right, well, for this point E, what is that change in y to go from the origin out to that point? What is that change in x? Well, that's simply the coordinates of the x and the y in this case. So that's going to be 6.7 divided by 4.4. And if we put that into our calculator, right, we get that that's about 1.52. So therefore, our equation is going to be y is equal to 1.52x. So we have a line with the slope of positive 1.52 going through the origin. Okay. How can we get the equation for the line in polar form? Well, one way to do it in polar form is to recognize what it represents. Well, here is a line that goes through the origin. right? This is a line that goes to the origin. So I could say, hey, I know that theta is going to be 56.5 degrees approximately. Why? Because theta is 56.46. That's going to be my angle, right? That it doesn't matter, right? It doesn't matter how I'm going to describe this line. This is always going to be the angle made with horizontal. But we have to be careful because this approach only works if I go through the origin, okay? The better approach to be familiar with is to know that I have y equals 1.52x. So using my substitutions, r sine of theta equals 1.52 times r cosine of theta. Okay. Now, in this situation, I have an r on both sides, and I know that r is not 0. Right, so if I go ahead and cancel those r's, I have that the sine of theta is equal to 1.52 cosine of theta. Okay, well, in this situation, the cosine of theta is not 0, so I can divide, and I could say that the tangent of theta is going to equal 1.52. And if I solve for the inverse tangent of 1.52, I get 56.7 degrees. And you might notice that, hey, these are not the same value here, and that is true. Those are not the same value. However, that's due to the rounding that we had, right? We rounded E here, we rounded this number there. So with the rounding, that's where we see a little discrepancy. Okay. And finally, A to E. Okay, if I'm going to solve for A to E is going to be like going from this point A over to the origin, and then from the origin out to point E. So I can write that as A to E is equal to A to O plus O to E, doing a little bit of vector addition. All right, so that would mean the motion from A to O is 8 in the positive x, 0 in the positive y. The motion from O to E is that 4.4 in the x and 6.7 in the y. And so then our result in component form would be 12.4 and 6.7. Okay. So that's a little bit of application of the various items with polars and Cartesians and vectors. Okay. This has been El Profilo. As always, if you have questions, please reach out.